Hello, I'm Hakan Eminçe. I'm head trainer at Festo UK. As Festo, we give training courses in pneumatics, electro-pneumatics, hydraulics, PLCs, and troubleshooting. Especially in terms of troubleshooting, we focus on common mistakes, reasons, consequences from real life. In this video, in partnership with RS, I would like to show you 5 tips for troubleshooting in pneumatic systems that might even surprise experienced maintenance engineers. I would like to show you a few tips today, okay, in terms of troubleshooting. In here, I've got the air supply and a machine. This cylinder represents the machine. So I've got one pressure sensor here, another pressure sensor at the end of the line. So we would like to focus on the pressure drops. So what I will do, press the button. Okay, so our machine is working. So the pressure on the left-hand side, 5.1. On the right-hand side, approximately 5. So we have less than 0.1 bar pressure drops on the system. So now what I will do, I will replace this tube, create the leakage on the machine. So have a look what happens with the leakage. So now we have the leakage on the compressed air line. So we will have a look if we can provide enough pressure on our machine. I turn the air on. We have the leakage. Machine starts. It is working. And stop. Okay? The machine stops because we can't provide enough pressure. The pressure we provided less than the adequate pressure. So that means the leakage on the line caused an issue on the machine. So as a maintenance person, we come to the machine, have a look at the alarm, but there is nothing wrong with the machine because the problem is on the line. We have the air leakage. This time, what I've done, I've taken my flow control valves out. So we have only one machine, we will run it. And then we will add another machine, that cylinder represents the second machine, and have a look at the pressure drops again. Press the button. You see our first machine is working all right. I will stop it. And now I'll turn the air off. Okay, everything is the same, but we have added one more machine, so our second machine is also working. I will start the cycle. It started and stopped. So we have a fault because we couldn't provide enough pneumatic power again, okay, because second machine is taking more flow. So what I will do now to overcome this issue, because the tube length here and also tube diameter and resistance causing our pressure drops. This tube diameter is only 4 mil. We would like to replace it with a 6 mil and have a look at the difference. This time what I've done, I replaced the 4 mil tube with the 6 mil, okay? So I will run 2 machines. You see our both machines are working because we are able to provide enough power. Earlier on, when we added the second cylinder, machine stopped and we had a fault. So there was nothing wrong with the machine. So you can replace any parts you like on the machine. Actually, there is nothing wrong with the machine because the problem was our tube diameter wasn't large enough, okay? So when we deal with troubleshooting, we need to make sure we can provide enough pneumatic power. Last time we had a look at the pressure drops and the leakages, but this time we have a look at the tube length and effects. In this example, we would like to have a look, the tube length between the valve and cylinder can create any issues or any breakdowns or can affect a number of cycles on machines. So let's have a look. I've got this tube, yellow ones, between valve and cylinder. So I will start the cycle. Basically, in 10 seconds, cylinder has been advanced and retracted 32 times. So now what I will do, I will replace the tubes with a longer one, simulating these tubes, they've been damaged, we need to replace them, but unfortunately we replace them with a longer one without realizing. So the longer tubes can cause some issues, we will have a look. The tubes has been replaced with the longer ones, okay? So we will have a look at the effect. I will run the machine 10 seconds, I have a look how many cycles we can run. Okay, in 10 seconds, number of cycles 28. With the shorter tube, it was 32. We approximately increased the cycle time a little bit more than 10%. So that means On our machines, if we replace the tube with the longer ones, we can create a delay. So that means if the cycle time of the machine depends on the cycle time of this cylinder, our cycle time will be increased, so we could end up producing less products. You see, that's very important. This time we will have a look at the speed control. I've got two one-way flow control valves to adjust advance and retract speed. At the moment, one-way flow control valves are installed in the right way around. Okay, run the machine. When I advance the cylinder, it took 1.07 seconds. So I will retract it. Now what I will do, I will replace only this tube, the one-way flow control valve, other way around. So basically, if we get confused, we can easily install them wrong way around. Let's have a look at what effects you might have. This one-way flow control valve is installed wrong way around, so we have made a mistake. So we will have a look, advance the cylinder and have a look at the cycle time. It took 2.16 seconds to advance the cylinder. Earlier on it was 1.07, so cycle time is increased double. So that means if we install one-way flow control valve other way around, we can easily increase the cycle time of this cylinder. If the cycle time of the machine depends on this cylinder, we may end up producing less products. That's very important. This time, we're going to have a look at the cushioning adjustments. At the moment, the machine is working all right, it's advancing and retracting. But what I will do, I will come here and turn the cushioning adjustment all the way in, okay? And machine stop. Because the cylinder cannot be advanced fully, some air is trapped here. So I haven't noticed anything. I moved and another maintenance engineer comes here and they said the machine is not working. To get the machine up and running, maybe next person will adjust the sensor, okay? So if they adjust the sensor, so they can get the machine up and running. However, this is wrong because we ended up changing the sensor adjustment. In the first place, cushioning must have been checked. This time, we would like to have a look at actuating these valves. We have a 5-2-way valve and double acting cylinder. This 5-2-way valve is pneumatically actuated spring return valve. So let's imagine we have a breakdown, this cylinder is not advancing. We need to check the actuation. Actuation is pneumatic. So let's imagine I've got this tube, air is coming out. We can clearly hear air coming out. On this tube, air is not coming out. First, we reckon this tube, that's the one causing the problem, not advanced cylinder, not this one. Okay, I will try the blue one first. Air is coming out. Cylinder is not advancing. Surprising, isn't it? I'll take this out. On the yellow one, air is not coming out. You can't hear anything. We reckon it's a problem. I put it in here, but the cylinder is advanced. So if we are in doubt, we need to check, not every single time, but once we are in doubt, we need to check the pressure. So I would like to show you where this blue and yellow lines comes from. Air is coming out. Earlier on we proved the point. This couldn't actuate the valve because this blue line comes through the pressure regulator. The yellow line, air cannot come out. Yellow line, air not come out because it comes through flow control valve. When we look at the pneumatic circuits, if the line comes through flow control valve or pressure regulator, we may need to check the pressure. To check the pressure, we can use the pressure gauge. So what I will do now, install this line, air is coming out. The valve is not actuated because the pressure we're applying, 1.9 bar. 1.9 bar is not adequate enough to actuate the valve. This time, I will take this out. No air coming out because it comes through the flow control valve, air is restricted. If I put this one back, the pressure is rising and we reach the 5 bar pressure. You can't hear it, but we have 5 bar pressure in that. So basically, once again, if the air comes to the pressure regulator or for flow control valve, please check on drawings, then you may want to check the pressure if it's adequate or not. In real life, in terms of troubleshooting, we keep replacing the parts. Actually, as long as we understand the principle of the products, We can recognize the components on the drawings and also on the machines as well, and know what comes in, what goes out, and we know how to check them. That really helps. Please also check out our video on how to reduce the energy wastage. And don't forget to like and subscribe for more practical engineering guides.